Happy Tuesday, everybody. Was everybody working hard on their exercise, identifying objects? So would you like to pass your answer sheets forward for the identifying objects? Thank you very much. Thank you very much. Is everybody very curious to see what a possible solution to that is? Are there any questions before we start about anything? If anyone has any questions or comments, just interrupt me anytime. So now I'm going to look at a solution to this exercise, identifying objects, right? So you're given a partial requirement specification, and your job is just to present a list of candidate objects according to the guidelines. Right? So here's a possible solution. The suspense is agonizing. If only we could add music to the spinning ball, like James Bond theme song. So how do I do this exercise? So given the partial specification below, identify a list of candidate objects. This exercise is to be done in groups. So there it is. So I start reading the partial specification, and I'm going through with my highlighter, and I'm highlighting all of the nouns. For example, I see drawing editor as my first noun. Then I have graphics editor as my second noun, but they're really referring to the same thing, right? And so I can start to create my list, right? Drawing editor as the first noun. So that's a candidate object. Graphics editor was a noun too, but it's the same as drawing editor, so I crossed it out. So users is the next noun, right? So I write down user. Remember, one of the guidelines is objects are singular by default. That's one of the guidelines. So I change users to user as a candidate object. Same with drawing. Drawing is a noun, right? So drawings is not a good choice for those things for a class name. The singular version is, right? So I put down drawing. There it is, drawing. And then I see lines, rectangles, ellipses, and text. So again, I change them all to singular. Line, rectangle, ellipse, and text. Tools comes up, so I change that again to singular, tool. Mode of operation. Now that's an interesting phrase, isn't it? Mode of operation, is that a noun? Well, mode is a noun, right? That is a noun, but I didn't put that on the list because I called that an information noun. Right? In the guidelines, you might remember identifying information words like quantities. So mode of operation I wrote down as an attribute rather than an object. So it refers to the editor. It's an attribute of the editor, right? And all those information nouns, they refer to the objects usually or the subjects of the sentences in which they reside. And then I have editor again, but look, editor is on my list already. Tool is there, right? And time. What about time? Is that a good object to put on the list? Does anybody have time on their list? Well, time, anybody want to take a guess at that? I don't see time on anybody's list. It is a noun, so it fits the... Yep. So time is a valid candidate object. It is. But I knew, oh, we're doing this assignment in Java, which already has a time object. So I don't need to create a new, well, currently, as far as I know right now, I don't need to create a new time object. So I left it off. But if you put it on your list, it would make sense. Creation tools. Well, creation tool and tools is on my list, right? Tool's already on my list. Selection tool, I'm adding that to the list. Creation tool is also added to my list. And then I have drawing elements. I changed that to singular and I add it to the list. Cursor. Cursor is also a noun. And somebody asked about it last time, I remember. We were talking about the cursor in one of the lectures. Did anybody put this on their list? Cursor? Yes. Some people have it. Zhao Yushin. Well done, well done. And Zhu Ruwan. Is that right? How do you say your name? Well done. Now, do I have it on my list? Yes, I do. There's probably going to be a Java cursor object, but it's still on my list because with the drawing editors, has anybody ever used a drawing editor before to make diagrams? Has anybody ever made diagrams with a piece of software before? So if you ever have done that, you'll notice that the cursor changes depending on where you place your mouse. If you place it on the canvas, the shape of the cursor changes from an arrow to a crosshair, for example. So it's always changing shape depending on what you're doing. So with that knowledge, I thought, okay, I'm going to put cursor as a special object because probably it's going to be very intelligent in this application. Maybe more intelligent than the standard Java cursor. Drawing elements is already on my list. Drawing elements is again there. They is a noun. I don't put they as an object. That would be pretty cool. But I try to figure out what is they referring to, right? Drawing elements, for example. Elements is the same as drawing elements. Current selection. I actually put down current selection as a candidate object because it looks very important. Current selection is mentioned multiple times, right? I see at least 3 times already here. So it seems very important. Control points I changed to singular and I put that on my list. And then element, and then all of the other ones are repeats. Repeats of the previous. So I go through very literally and just highlight the nouns and construct my list. following the guidelines. Identify all the nouns, write down all the nouns in singular form. Right? Now, some of you broke one of the rules and put down things like lines as an object instead of line. Right, that's one of the rules is use the singular form of the nouns. Right, so that's a very important rule. If you wanted an object that manages a number of lines, what would you call that object? You wouldn't call it lines. Any ideas? You'll find this pattern over and over again everywhere in software development. You'd call it a line collection object. You could also call it a line manager, something like that. But anytime you want a plurality, you'd call it a collection object. In Java, there are, I don't know how many hundreds of collection objects and in other software. And so I've made a note of that. I could introduce implicitly a shape collection object or a line collection object if I wanted to. That's implied in the specification that I'm going to need some object that manages collections of objects, of individual objects, right? And I have ... here. So for all the plurality, we could have collection objects. And then just for the fun of it, I went through my list again after I finished, and then I just noticed the related objects. So a drawing is composed of lines, rectangles, ellipses, and text. I just made a little mental note like, look, these belong together. And look, this also belongs here. They're all related. They're conceptually all related. Right, they follow something called the is-part-of relationship, which we're going to talk about. And somehow these are all related too, right? Tool selection tool, creation tool. Somehow they're related. Does anybody know how they're related? We could say a selection tool is a kind of tool. It's a type of tool. That's something we're going to talk about. And we see that these two are going to be related too, right? Cursor identifies, probably you click on an element to get current selection to identify it as the current selection. Now, is this list perfect? No, it's not perfect. We're going to go back and modify it as we proceed. But this is step one. Current selection might turn into an attribute of an object. It might. It might be its own object. It might turn into an attribute of an object. It might even be both. We don't know at this point, but right now we've just got our list of candidate objects. And then we have this control point, which is kind of lost and by itself. Maybe that belongs up here, these objects. So everybody think they understand that? Does that make sense? Any comments or questions? Now I hope if I use my psychic powers and I try to read your minds, I hope that you're thinking, well, I think that you're thinking, wow, that's easy. I hope that's what you're thinking. That's what my psychic powers are telling me right now. That's the waves I'm getting. Like, wow, that was it? That's easy. It is. That's easy. It's a simple exercise when you know how to do it. So, good. So let's continue from where we left off last time. As you can see, there's another exciting exercise coming up. Very exciting. Not quite as easy as the first one. So where are we actually? Responsibilities. So 2 weeks ago, we'll just have a little tiny 15-second refresher. We started talking about responsibilities, which don't correspond to nouns. Does anybody remember what responsibilities correspond to? Which part of speech?
Verbs.
Verbs, exactly. And possibly information nouns too, like quantities. And we went through the rules and guidelines of identifying responsibilities, right? And then we go through the process of trying to assign responsibilities to objects, right? And we try to distribute the intelligence amongst a collection of objects rather than centralized intelligence. So those are the responsibility guidelines and intelligence and so on. And that's what we talked about last time. Now we're going to look at examining class relationships, looking at how to analyze and identify the relationships between classes. So classes have different kinds of relationships. Does anybody remember one of the relationship types that we already talked about? That's kind of, you'd have to be really paying attention and have good memory to answer that question. It's not a very difficult question though. We did talk about one kind of class relationship. We didn't really call it a class relationship, but we were talking about what kind.
Subclasses.
What did you say?
Subclasses.
Which classes? Subclasses. Yeah, you're right. Yeah, we talked about parent and child. Well done, well done. What's your name?
George.
George. Well done, George. The one I was thinking about was the client-server relationship, but you're right too. So we talked about other relationships too: the parent-child, subclass, superclass, and client-server relationships. Right, so there are a few that appear over and over again. Like the client-server appears over and over again. Here's another one. Is kind of and is part of. These two appear over and over again, and they already appeared in the first exercise. Right, a drawing is, or a line. A line is a part of a drawing, for example. And the selection tool is a kind of tool. So we already saw these two relationships in the first exercise. Let's talk about these in a little bit more detail. These, just for the fun of it, by the way, a little story. When I was working as a software developer at my last job, I could identify that I was working on a failing project because I noticed that the developers were not following this rule. They didn't know what an is kind of relationship was, and they didn't know how to distinguish that from an is part of relationship. They just didn't know. So I could see the way that the relationships between their classes weren't making any sense. And that was another clue. Oh, I'm working on a failing project. That wasn't the only clue, but that was one of the clues. Another clue was not all of the objects were nouns. So some of the objects were verbs. So I knew, this is probably it's another piece of evidence that this is a failing project. Like, they might have an object just called something like delete or save, right? That's the sign of a failing project. It's not the only sign. Anyways, so when we finish this module, we're going to have this area sorted out. We're not going to have to worry about this. If one class is a kind of another class, look for subclass, superclass relationships, right? Or parent-child relationships. A child is a kind of parent, basically. Shared attributes can imply an is kind of relationship. And we're going to always refer to this drawing editor. From the drawing editor, we could have a text creation tool, a line creation tool, and there are all kinds of creation tools. They share 3 responsibilities: accepting user input, determining the location of a new drawing element, and creating a new instance of a drawing element, the constructor. So if the shared responsibilities are assigned to the parent class called creation tool and inherited by the others, only the second one is likely to be implemented by a child or a superclass, or the superclass rather, the parent or the superclass. So determining the location of a new drawing element. The others are probably going to be implemented by the child classes, the accepting user input, in creating a new instance of a drawing element. Now, I think this is the relationship that everybody understands, at least in my experience. When people develop their software and create relationships between classes, they usually use this relationship and they usually understand it. What people usually don't understand is this one, and they get the two confused. So this is not the relationship between all classes. Some people think, they see that expression is, if all you have is a hammer, then everything looks like a nail. Heard that expression. Anyways, not everything is a nail and a hammer. So is part of it. You might also be thinking, is this complicated? No, it's not complicated. It's really simple, actually. It's as simple as it looks, but still people get it confused. What happens if a class seems to be a part of another class? Objects of one class is part of objects of another class, and there is no shared behavior necessarily implied by the is part of relationship. Is part of defines an object hierarchy, not a class hierarchy. So my arm is a part of my body, right? That's a composite relationship, or is part of relationship. My hand is a part of my arm. My finger is a part of my hand. Does that make sense to everybody? It's very simple, isn't it? It is very simple. But people get this very confused with the is kind of relationship. So I cannot say, what do people do a lot in reality and get confused? They say, my arm is a kind of body. This is how they'll define a parent-child relationship in their software, and that's just incorrect. And how do you know if something is correct or incorrect? The natural language will tell you. The language will tell you. If I say, my arm is a kind of body, that sentence doesn't make any sense. It's wrong. If I say my arm is a part of my body, that sentence makes sense, right? And hand is a part of arm, and so on. In the editor example, we saw these relationships. A line is a part of a drawing. A rectangle is a part of a drawing. Those are composite relationships, or is part of relationships. You would never say something like, text is a kind of ellipse, or something like this. Right? So the natural language expression has to make sense. And you can just test the natural language. I've seen students get this mixed up. I've seen software engineers in the real world get this mixed up. That's another reason I knew I was working on a failing project at my last job. Because I could see that the engineers were using, they wanted to express the is part of relationship. That's what they were thinking, but they were trying to do it through class hierarchies, parent-child relationships, and that's just not correct. That's parent-child relationships are the is kind of relationship. This is implemented by membership. So when one object is a member variable of another object, it's a member, not a child. An object is often composed of parts and has responsibility for those parts, but not vice versa. What does that mean? That means I can take this arm and my body knows about my arm, but the arm doesn't have to know about the body. The body controls the arm, but the arm doesn't control the body. I can chop off my arm and attach it to someone else's body. Yeah, so that the arm doesn't have to know about the body. And the same is true about the hand. The hand doesn't know about the arm, but the arm knows about the hand. Right? And the same with the finger and the hand. Remember, we're still talking about responsibilities. These are relationships, class relationships in the context of responsibilities. So there could be some unassigned responsibilities. So difficulties in assigning responsibilities can occur if a class is missing, right? If we identify a list of responsibilities and we try to assign them to their classes and we can't figure out some. Maybe, for example, there's some implied objects. There are implied objects and implied responsibilities. We may need to add a class to handle a set of unassigned responsibilities. For example, the drawing editor needs to assign grouping responsibilities. A new group element class is best. Right? In a drawing editor package, you can select, say, three rectangles and then clasp them together in a group and then move them all around together as a group. A responsibility could be assigned to more than one class. Sometimes it's not so obvious. So make a tentative arbitrary assignment and then try a walkthrough and see how it works. So that's unassigned responsibilities. And now this is your first tool. This is just first software design tool. It's called a class card. So this is how we actually write down the responsibilities. We list responsibilities on class cards. By the way, there's a note here, don't list parents' responsibilities with the children. So this is a card, and we have one card per class. Right? And the class, I guess the floor is shaking, isn't it? Yeah. Because the projector is shaking. Must be a really interesting lecture going on downstairs. So the name of the class is here. This class is called Creation Tool. It has a parent class called Tool. So Creation Tool is a kind of tool. That's the is type of relationship. Then it has child classes, Line Creation Tool, Rectangle Creation Tool. Right? So Line Creation Tool is a kind of tool. Line Creation Tool is a kind of creation tool. So they both, the natural language works in both of those. And then we have responsibilities, accepting appropriate input, determining location, and creating a new instance. And we document that on a class card. That's our first software design tool. It's called a class card. And it's a card that describes a class. It has a name, the parent classes, the child classes, and the list of responsibilities. Any questions about that? Okay. So let's start the next one. This is the collaborations stuff. Collaborations. There's a 15 version. So we know how to identify objects now. We know how to identify responsibilities. We started talking about class relationships, and now we're going to talk about collaboration. So that's communication between classes, like collaborations. So collaborations represent a request from a client to a server, right? The client has the responsibility to perform, has a responsibility to perform. It may be able to fulfill its responsibility without any help by itself, or it may need help from other classes. So in the case it needs help from other classes, it turns into a client, right? A server provides services representing its responsibilities. A single collaboration is one way from the client to server, but that does not mean that information only flows in one direction. So this is a diagram of a collaboration, right? Class A has a responsibility called A1. So, and this is the communication from one class to another, this edge. So there's some client class here, and it wants some information from class A. So it asks class A for some information, but class A cannot provide the information or fulfill the responsibility by itself. So it asks class B and class C for some information, and they return the information back to class A. So for example, get time, right? Well, that's not a very exciting example, but that's the idea. It says, does not mean that information only flows in one direction. So in the exciting get time example, you might specify a time zone, right? Get time, and then in the method get time, there's an argument that takes the time zone, GMT. So that's information, the time zone flowing from class A to class B. And then the information that goes back is the time. So information is flowing in both directions in the form of input parameters, method input parameters, and return parameters. Always. Right? Each collaboration addresses one responsibility in the server. Okay, each collaboration helps to fulfill one responsibility of the client. But one client responsibility may need many collaborations. So patterns of collaborations represent the flow of information in your software. This is the difficult part of object-oriented design, by the way, and the difficult part of object-oriented software. This is what makes it difficult, is trying to understand the flow of information inside an object-oriented design system. So patterns of collaborations define the communication patterns, and they help to identify subsystems, which leads to another level of encapsulation. So we have a special lecture just on subsystems. So we know how to find objects, we know how to find responsibilities. Now we're going to try to find collaborations, patterns of communication between the objects. Finding collaborations, we look for client-server relationships or dependencies among responsibilities. So we go through this process. For each responsibility of each class, is the class capable of fulfilling the responsibility by itself? True or false? If it's false, what other classes does it need in order to get help? From what other classes can it acquire what it needs? Shared responsibilities also define collaborations. So we're going to go through examples of this, by the way. We need to know for each class, what does this class do or know? and what other classes need these actions or information. By the way, if a class doesn't interact with any other class, it might be something that we can eliminate. But that's not so important. Keep it by default, I would say. So we're going to rely a little bit on our class relationships to identify class collaborations. The is part of relationship corresponds to a collaboration. Right? Is part of the hand, is part of the arm. Right? The is part of relationship defines a whole part relationship between two classes. One class is a composite of object, the other is a component. So in the hand and fingers example, the hand is the composite object and the fingers are components. You'll hear me use that term a lot, composite objects. Composite objects usually have the responsibility for maintaining information about its components. For example, how many fingers do you have? The answer is not always the same, by the way. Has knowledge of is another kind of relationship that corresponds to a collaboration. So if a class A has knowledge of B, it usually implies a collaboration. Typically A collaborates with B or asks for a service through a server, though a server may need to have information from the client as well. Right, all the drawing elements like lines and rectangles and triangles and shapes, they all have control points or the vertices. Right, every line edge has two vertices at the end, which are also called control points. Right, so a drawing element has to know about its own control points. The control points don't have to know, by the way, which drawing element they belong to. A control point object just knows about itself, where it's located, how to update its location, and so on. It doesn't need to know about if it belongs to an edge or a circle or a polygon. Depends upon is also another way we can find class relationships or collaborations. Very similar to has knowledge of, but maybe a third class that makes and maintains dependencies. So this is a bit confusing. The composite versus container objects. So I use this term composite object a lot, but it's not the exact same thing as a container object. So composite objects are object hierarchies, and container objects are things like sets, arrays, and lists. What does that mean? A composite object is composed of different parts. A container object is composed of all parts that are the same. So each component has a different role to play in a composite object. Like a car, right, is composed of wheels, steering wheel, a seat, a motor, a frame, yeah, the dashboard. Those are all different parts. So the car is a composite object. Not a very brilliant description of a car. A composite is responsible for its parts. It knows about its parts, but the parts don't know about the composite. So I can take the wheel from one car, theoretically kind of, and put it onto another car. When we manufacture tires, right, they can go on different cars. So the cars have to know what tires fit on it. The tires don't need to know about that because they don't know which car they're going to go on necessarily. Composites collaborate with its components. Container objects are sets that are all functionally identical. So elements in the container are functionally identical as far as the container is concerned. They all serve the same mold. And containers may need to collaborate with their elements, but usually the container responsibility is just passed along to all the elements. So an array is an example, a set, a list, an array of integers, right, an array of strings, and so on. Pretty simple. It is simple, actually. It's just the terminology that's confusing. But it is simple. Okay, so how do we write down the collaborations? This is the class card again, but we've added some new information on there. So it's the same class card creation tool. We have a superclass called tool. We have a subclass called line creation tool, rectangle creation tool. It's the same one. These are the responsibilities: accepting appropriate input, determining location, creating new instance. And these are the collaborations. So this class creation tool collaborates with another class called user input, and drawing elements. Right. If a client responsibility needs two collaborations with the same server class, write the name twice. If responsibility requires collaboration with another instance of the same or parent class, include that class as well. So that's our class card, expanded now, but with collaborations. So the first assignment, which Tom is going to delightfully hand out next week, is going to ask you, it's going to give you a specification, and you create these cards. Right? You have to go through identify the objects, go through identify responsibilities, identify collaborations, and construct these class cards as part of your design. Sounds exciting, doesn't it? I can see the level of excitement is through the roof. It's about to get even more exciting. So the next in-class exercise, responsibilities. So this is also done in pairs. Is everybody excited for this? It is exciting. You guys only want is a team or three? So, given the partial specification below, it looks very familiar, hopefully. Identify a list of candidate objects and their responsibilities. So it's not just the objects now, it's the responsibilities. Record them using a class card style. Refer to the lecture on responsibilities for guidance. This exercise is to be done in groups. So it's a continuation of the last exercise. It is not as easy as the first one. It's true. Identifying responsibilities and then putting them together with their classes is not quite as easy as just identifying the objects. But you have the solution to the first exercise already, so that's a big help. So there are some of the guidelines. These are not all of the guidelines, but from our responsibilities lecture, these are some of the guidelines. There are other slides, but the most important slide is the one I just showed. So this is also important. You can put a star on slide number 10, and you can put a star on slide number 3. 10.3. Yeah, 11 is good too. Put a star on 11. So everybody remembers what objects correspond to which part of speech? Anybody remember which part of speech that objects correspond to? Is the attendance register somewhere? Nouns. Who said that? Well done. What's your name? Nice. So anybody know which part of speech responsibilities refer to? Verbs. And information nouns, like quantities, the amount of something, like the width of a rectangle, for example. That would not be it. Width would not be, well, width is an adjective, actually. But you can imagine some information nouns, like the radius of a circle. Are there any extra copies that responsibilities have been read? Extra copies? Okay. It's okay. I don't absolutely need a copy. Okay. I remember the very first time I gave the exercise on identifying objects to the class. I gave out the exercise and the class didn't do very well. I can see that this class did pretty well. And I couldn't understand it, and then I realized, oh, I left out the slide on that says like guidelines for identifying class objects. I left out the slide, that one magic slide, the most important one. Oh, I better include that next time. Do you guys do any in-class exercises in your other lectures? Not so far. It's a little bit shocking to you. I get the feeling that some people are shocked that they have to like suddenly do something rather than just watch the lecture slides. Any questions? You're allowed to ask questions. What is that? That's an iPad Pro. It's huge. It's really big. It's pretty cool. These exercises will be very helpful for your first assignments, right? Because you do this in your first assignments. Tom, can I just see if I can give you the assignment every time? Thank you. Does everybody feel like they know what to do, roughly? Oh, that's a good question. Do you have to identify collaborations? No. Collaborations is not part of this assignment. This is just responsibilities. So at the end of the responsibilities lecture, we have this class card. There are no collaborations. Right? Good question. Any other questions? Okay, so on the first exercise, Elliot Cook and John Plessis. Very good. Which team is that? You guys. Very good. Very good.
On the B side of things, is that what you're getting at up there? Did you go to section 8 to stage 8?
Yes.
That's what we got to. That's what you're asking, isn't it?
That you started to identify class relationships, the parent-child relationships, and the composite relationships. That's what you started to do. That is related to responsibilities. It's not exactly the same, but it's related.
It's in there, isn't it?
It's related, yeah. The Zhao Yushin and Zhu Ruan, that's also very good, but there's just that one rule they're not following, the plurality rule, so objects are singular by default. So I hope for Yang Du, is Yang Du here? And Ajin Lee. I hope that this first exercise makes more sense to you now that you've seen the solutions. Yeah? Does it make sense now? Good, good. Okay, Wang and Zhu. So Wang and Zhu here. They got a little bit confused with assignment 1, exercise 1 rather. Again, make sure you have the singularity rule in place. Same with Reese Barnes Bennett and Robert Laughlin. You need to have all your objects be singular. Some of your objects are plural, and you missed some. Chris and Daniel, Chris Smith, does this make sense to you now? Does the first exercise make sense to you now that you saw the answers? Or a set of solutions. And same with Zhao Zhao Lu, is that you? And Jing Zhao. Does the first exercise make sense to you now that you've seen the solution? Okay, good. That's why we did it. Any questions about the second exercise? Okay, so I would like you guys to finish the second exercise between now and the beginning of the next lecture next Tuesday, and hand it in at the beginning of the class lecture next Tuesday. Happy Tuesday.